Wir wollen jetzt in den kommenden 1,5 Stunden über Erfolg sprechen, über den Erfolg deutscher Unternehmen im globalen Kontext. Und vor allem wollen wir auch darüber sprechen, wie wir denn den Erfolg deutscher Unternehmen auf dem globalen Markt nachhaltig sichern können. Wir sind ja in einem Zeitalter, in dem Globalisierung und Digitalisierung Erfolg ausmachen und in der Zeit ein ganz, ganz kritischer Faktor ist und der Innovationsdruck wirklich enorm hoch ist. Also das wollen wir gleich besprechen. Wie bleiben wir wettbewerbsfähig? Und wir bekommen jetzt vor dieser Panel-Discussion ganz, ganz wichtige und auch interessante Eindrücke, Impulse, Visionen von Steve Lewis. Und Steve Lewis ist der CEO von Living Planet und ich glaube, ein Mensch, den man wirklich als echten Global Citizen beschreiben darf. Er hat in so vielen Ländern gelebt, in Großbritannien, im Nahen Osten, in Deutschland. Deshalb darf ich ihn übrigens auch auf Deutsch ankündigen, weil er auch Deutsch spricht. Sollten ihn gleich mal fragen, wie viele Sprachen er insgesamt spricht. Er hat in Australien gelebt, er hat in den USA gelebt, er hat in Japan gelebt, er hat in Südafrika gelebt, hatte dort auch das große Privileg, das ist an so einem Tag vielleicht auch wirklich erwähnenswert, Nelson Mandela kennenzulernen und mit ihm einen kurzen Moment Zeit zu verbringen. Und dann hat er sich letztendlich für Portugal entschieden, um dort jetzt zu leben. Er ist ein Top-Manager bei Microsoft gewesen, viele, viele Jahre, bevor er sich dann entschlossen hat, seine Expertise, sein Know-how, seiner Vision komplett zu widmen. Living Planet ist seine Vision, eine Vision von intelligenten und von nachhaltigen Städten, die durch neue Technologie effizienter gestaltet werden können, natürlicher mit Ressourcen umgehen oder schon damit natürlichen Ressourcen umgehen und so eben für uns alle auch nachhaltig lebenswerter sein sollen am Ende des Tages. Er ist dafür schon groß ausgezeichnet worden. Das World Economic Forum hat ihn als Technology Pioneer im vergangenen Jahr ausgezeichnet. Das ist wirklich eine ganz, ganz große Ehre. Und er ist Mitglied der Royal Society of the Arts. Und das ist natürlich auch etwas enorm Besonderes. So, nun sind wir gespannt auf seine Vision und auf seine Impulse. Herzlich willkommen, Steve Lewis.
So good morning. I will apologize at the outset. My German is not bad, but it's not good enough to impress you guys today. And I also would like to remember a great man we lost overnight, Nelson Mandela. I've got a couple of topics to cover. Fortunately, I've got 20 minutes to speak, and I've only got 1,262 slides. So I will try to cover them as quickly as I can. My background is principally software engineering. I came to Germany in the first instance because I fell ill and I was treated here in Heidelberg many years ago. But it always has been very obvious to me the role that German industry, German companies, German people have played in the evolution of some of the most important technologies and innovations that we grace the world with today. But we're entering a very interesting and difficult time. The rate and pace of innovation is dramatically accelerating. We're becoming a highly digitalized economy, and we're dealing with massive urban shift, not only in the developing world, but also in the developed. So I wanted to share a few reflections I've had in thinking through our business over the last few years and try to share with you some of the, I think, opportunities as well as what I think some of the challenges are. So, less to do. This to me is Germany. Fantastic precision, great quality. You care about the environment, the things you build work. It's all about safety. And it's a fantastic representation of German engineering and innovation for the world to see Germany in that way. I'm going to talk a little bit about how that evolves into having, I think, an even greater lasting effect on our world and humanity. First topic, industrialization of the internet. We've gone through 3 phases of the evolution of the internet. The first was started by the military, adopted by universities to share content, documents. Then we moved into the phase we're most familiar with, which is the Twitterverse, the Facebook world of social media and collaboration, and adopted at some point in technology for businesses. And now we're moving the internet towards the next major utility, where it becomes a completely reliable, robust infrastructure for the most mission-critical things that happen in our daily lives. To go forward, I want to start by going back. Top left-hand corner here is the Hubble telescope, which was launched in 1994. Took 4 years to build and craft and looks billions of years back into our history. And the picture you're seeing in the top, very top left is a star that imploded some 250 billion years ago or something like that. Very complex control system and a lot of sensing. And then we move to the Mars rover, the Curiosity rover, that has an onboard laboratory for studying minerals and other artifacts on the planet. And it has a communication system, a power system, and a bunch of other things on it. Next middle row, you see Google Earth, which all of us have probably hit at some time, or Bing Maps. And in that, you're seeing to the right the measurement of methane coming out of the ground in San Francisco, because we mix methane with natural gas so we can smell it, humans, so we can avoid explosive moments. This happens to be some sensors on a few taxis driving around San Francisco. And this is the volume of gas coming out of every street in San Francisco. On the next one along is us layering that data in so I can follow the pipes along the street for maintenance. The one on the right in the middle is people movement, studying how people come during moments of quite severe anguish when there's a fire threat or a bomb threat in Canary Wharf. This is looking at the pattern of behaviors as people exit buildings. The bottom is some advanced research work that we've been doing where we've been genetically modifying bacteria to consume things they wouldn't normally. This happens to be Tetra Pak, which we wrap our orange juice and our milk in, that doesn't biodegrade very easily. And this is bacteria eating away all the petrochemicals, turning it into biodiesels and biofuels, stripping out the aluminium that can be resurfaced and producing water as a byproduct. The next is deep ground penetrating technologies using photon lasers hitting molecules 4 kilometers in the ground and using spectrography to figure out what the mix of those molecules looks so we can find not only minerals and other resources, but we can manage our water table, find ground source heat to convert to energy, and a whole range of other geological stabilization data. And then here's nanoscale. We're looking at the bonds between atoms. This work was actually conducted by IBM at CERN. In the period of 20 years, we've gone from spying on the world or the universe to looking at the very particles that our world and universe is made of. We've also taken another huge leap. As of a few months ago, we have some software that now can talk to microbes, send them little packets of information in the form of antibiotics, change their genetics, and then they talk back to us by sending us amino acids that give us certain light off. And that light frequency, we can tell what it's doing. And so we're looking at using these microbes now instead of electronics for sensing the physical world. I can see what's going on in the air, I can see what's going on the ground, and I could also make microbes be little robotic machines. Sort of state of the art. We are moving into a period over the next year where we will start wearing the internet even more aggressively. Interestingly, as of 2 weeks ago, NASA was able to send data to a satellite spinning around the moon at 622 megabits per second. And that data capacity is moving to platforms on Earth to enable these types of communication, driven by health as well as gadgetry. The internet is becoming part of us. This was developed by Michigan State University. It enhances visual apertures of the eye and actually has a wireless radio frequency that it uses to communicate with the outside world. So not only the viewer is able to see, but viewers of the viewer can see. And this is probably one of the most advanced applications of sensing yet on the planet. It's a digital tattoo that is laid onto the body. The body's heat gives it its energy, and it communicates what's going on in physiology. This is a profound shift in how we think about the internet. If today your broadband modem at home was responsible for managing your pacemaker in your heart, you'd probably be quite concerned. But as we evolve and industrialize and harden, we are definitely moving to this space. Ultimately, we end up with many things talking to many other things. This is the era of machines talking to machines and machines talking to people. There are lots of guesstimates of how many of those things will communicate, but if you add microbes to the list, we're talking about trillions of things in a very short period of time. And everything that we touch, feel, and smell becomes able to sense. So that's one huge technological shift. For me as a technologist, the most exciting shift in technological evolution and the opportunities that come with it to commercialize it in every form of improving quality of life. Second major trend, massive urbanization. London has grown in the last 15 years by 58% as a population. We think of urbanization as a developing world phenomenon, but it's happening in our cities, not only through migration, but also through consolidation. The developing world has even greater challenges. They've got huge disparity in terms of economic opportunity, huge disparities in social access, massive issues in lack of resources, and so their shift to cities is even more poignant and more aggressive than ours. We're sitting in a world with beautiful infrastructure. They're starting with a clean sheet in many cases and adopting technologies as a result much faster into their core, and that builds environments where human competitivity accelerates. Here's an example of a European city. We happen to be building this one. Here's a new city in Brazil in the north of the country. There are tens of thousands of this scale urban environment containing 2, 3, 4, 500,000 people being developed right now. The process of delivery is a challenge. Construction is like watching a 9-year-old's football game. Nobody really has any strategy much at the beginning. They all get together and kick the ball around, chase it, and hopefully you get to the end of the game. Construction is the least efficient industry known to man. It makes horrid use of our natural resources. It's extremely capital intensive and wasteful. It gets delivered slow, and then it doesn't function, and then it ravages our environment. And so what we're seeing is a shift to apply the techniques that have been used in other manufacturing sectors, whether it be aerospace or automotive, whether it be in shipbuilding or any other large capital asset design and delivery. Those techniques are moving in to the construction industry, where we're starting to design and simulate and fabricate these structures in fundamentally different ways, with the benefit that we reduce 30% of the CapEx, we reduce 40, 50, 60% of the OpEx, solving the problem which everybody asks is, how do I get to sustainability? How do I afford sustainability? Well, if I reduce the CapEx, I can afford a lot of new materials, new technologies, new techniques. This is an example of city simulation. On the left-hand side, this is taking some 10,000 variables and maximizing the use of the topography, the infrastructure, and human interaction. The middle one is looking at where do I put city services and things that I'm going to consume so I can put it within 3 to 4 minutes walk of everything I need to do on a regular basis. I want that 3 to 4 minutes walk because if I do that twice a day, I reduce heart issues by 50%. I reduce liver disease by 70%. So we have to think about the economic, the social, and the environmental aspects of these new places. The one on the right is using airflow simulation, similar to what you would find in Formula One. We want to slow the air down on the ground. So in a warm society, in a warm topography, I want to keep the air at a certain temperature. But I want to speed it up over my buildings so I can cool my photovoltaic systems and I can speed up my micro wind generation. So we're looking at these as systems, which requires immense amount of industry, collaboration, and massive diversification of the skills that have been traditionally in here. This is the design of a building, layers and layers of detail. Designed from the outset to be assembled like you would an aircraft, but going in then to those systems in these buildings. And the little dots you see on each of these floors are packages of sensing that become part of the framework of the building. It gets there because I want to know how my concrete is curing. I want to know whether my concrete is deteriorating. I want to know whether somebody is moving around. I want to know that my structure is safe. But I also want to be able to interact and change the building use over time, because who knows how this building will ultimately be used 20 years from now. So give you an analogy of the two things coming together. And I'm going to use, I apologize to my former Microsoft colleagues in the audience, but I have one of these. It's an iPhone. And it has 5 or 6 sensors in it, as do most smartphones. It's got a light sensor, accelerometer, a gyro, some other things. And we've built lots of applications on it. Today, there are about 1 million applications producing $16 billion a quarter in revenue. Just to give you an idea on a worldwide basis. Now, we talk about iCities. Cities where we have immense density of sensing and control. The city I was showing you in Brazil will have about 1 billion sensors to start with. That's before somebody shows up with a device. That's just the city. And so when you look at the tens of thousands of classes of things I can sense and manage, I can build a lot of applications off that stuff. And I can build a lot of analytics to understand not only improving efficiency, but improving quality of life. Effectively, you end up with this big urban app store view of the world. The city is the infrastructure. It's its own cloud. And everything talks to everything else in a very simple and methodical fashion, but extremely exciting. The types of applications we see in everything from building it, to managing it, to measuring it, to really clever things. Now, I'm going to embarrass our kind host here for a second. Can you just come join me on stage? This is an example of...
I usually don't like things when I don't know what I'm getting myself into.
I promise.
But okay, I'll be brave.
It will never hurt much. So I'm just going to point this at you for a second. So what I'm actually doing is using the camera to measure your heartbeat, which is your left-hand side, and your breathing on the right-hand side.
I usually have a very quick heartbeat.
Yes, you do, in this particular moment. Thank you.
My doctor's always very surprised.
Yeah, very impressive. Thank you. This camera could be anywhere. It could be the camera in this room. It could be the camera in my mum's home. It can be anything, anywhere. And I'm able to look at vital signs in a very rich way. In fact, accurately enough to make serious medical decisions on it. That's talking across a network, doing its stuff over here, coming back to me with data. We start to see street furniture change. This is an example of a smart post, street lamp. Yes, it reduces the use of energy load for the light, but that's the boring bit. It also samples the environment, it speaks to me, it directs me, and it keeps me safe. We're putting this stuff, our technology is in, it came from Formula One initially, but we're moving as an industry, the automotive segment is now sensing and interacting and extending what the car sees, what the car feels, and how it interacts with the rest of the world. To doing some really important things like reducing child mortality. This is using the same technology in air ambulances, ambulances on the road, and in the building of the ICU, the intensive care unit, where the building is reading the physiology of some of the sickest children that we have in our societies and giving us real-time data on how they're responding to treatments in their environment. These new places surround us from the moment we wake up in the morning. On the left-hand side, this is some new technology from Corning glass, which can project images in 3D into space. The other is natural dimming of lighting surfaces like windows using electrical energies, the coding. This is my data coming to me. I'm up in the bathroom. This is obviously not me, way more attractive than me, where my data is now going to where I want to be in context. And whether it's in the surfaces of my home, the inside of my automotive environment, whether it be at my workplace, whether it be anywhere else. And the way that we interact will fundamentally change. And this drives massive dissemination of learning, competitivity in terms of the speed at which economies can respond to opportunity, the way we share our learning, and how we ultimately succeed. Whilst we look at ourselves as nations, we will start to think about the economies of cities being the driving differentiators of our societies, because it's where our people are. This is an example of my home, telling me that one of my staff's girlfriends entered the house at 9:05, left at 9:11. She always leaves something. My security turned itself on. Now, Bob had some water. Bob is my dog, my puppy, at home. And he drinks quite a lot, and he leaves a lot of it around the house at the moment. So where's all this heading? The challenge that we all strive for when we divide ourselves in our various clusters of citizenship, we're ultimately all striving for the same thing, whether you're a kid in Delhi or you're a kid outside here in Frankfurt. You want to have a life of self-determination, you want to be safe, you want to have access to healthcare when you need it. I need education. I need to have these rich set of things that allow me to fulfill my potential. The developing world is having to move faster than everybody else because of the instabilities that a lack of economic activity creates and a lack of prosperity creates. But in this strive, this global strive for improving and fulfilling our complete potential creates significant opportunity. Cities are very large manufactured kits of parts. They consume everything the German economy produces. But we're building trillions and trillions and trillions of dollars of them over the next 5, 6, 7 years. It's a dramatic state shift that requires immense collaboration. When you look at some of the most exquisite goods that are produced in Germany, it's a collaboration between the brand, suppliers, other knowledge providers, small guys, lots of industry, innovation. This city problem takes this to a whole new scale. But if I was looking at one area of economic growth for Germany right now, it's in this area. The world loves German goods. They trust you guys. You build good stuff. They have aspirations to live those types of lives. So critically is how you organize to go after what is the largest single market we have, is urban shift, converging with the Internet of Things. It has a consequence for your businesses. We like to sit at home in Germany, build our towers, have all of our staff at hand. But to have the right to enter these territories, they're looking for something more. They're looking for knowledge transfer. They're looking to have an intimate relationship with you in their territory. And so we end up moving in an uncomfortable way to a much more decentralized philosophy in our businesses because we have to be there where the there is. We can't do it from sitting in Central Europe. Anyway, they were my thoughts. Thank you so much.
Thank you very much.